Okay, so a bit of a surprise. I'm going to talk in English. Hope that's not a problem for you guys. So thanks for introducing me. Continuous delivery and beyond. So first, a question: who is working in continuous delivery? Okay, who thinks they succeeded in continuous delivery? Okay. And who is working with microservices? Okay, some hands. So hopefully, for at least you people, this presentation will show you something interesting. Okay, so about me, as Łukasz already mentioned, I am a senior QA engineer at Cognified. We are a software house, British, Polish software house stationed in Poznań and Bydgoszcz now. And I also started recently to blog at automatingguy.com. You can follow me on Twitter. And by the way, Twitter is not only a platform for bragging about anything, it's a great tool to actually get some extra knowledge from world experts. So I encourage you to at least create an account and follow like some of the testing people famous in the world. So it's really worth to do that. What I am going to talk about is making continuous delivery more complex than it already is. So not intentionally, of course, that would be a bit silly. So the context here is switching from a monolithic architecture to microservices. Really interesting switch, at least for our organization, as this is one of the first projects that actually made that change. And it brought a lot of challenges, let's say. But I hope that I'm going to show you some fundamentals that will prepare you if your organization is supposed to make such a switch in the future. So different people talk about different elements when talking about continuous delivery. For me, these 5 are the most important ones. So tools, of course, this is our CI/CD system, our test frameworks, our infrastructure, how we define our infrastructure, how we provision it, how we in general manage that. Second one, the development process. So how we are supposed to deliver things continuously. How is our code flow modeled across our environment? So from the very beginning, before we even start implementing stuff, to the very end where our end user actually gets that code. And maybe a surprising item, the third one, proper backlog, because defining things in a way that we can actually deliver them continuously is really, really important and played a key part of what we actually did. And it's also quite hard to do. So I'm not saying that we found the sweet spot yet, but we are getting there. Of course, we are not doing things for fun. There are people paying us to do some of the things that we do. And business process. So how are we working with the business stakeholders, be it your client, it can be your user. So how are we working with those people? And of course, DevOps culture and mindset. A lot of presentation already mentioned that. Great workshop with Tomasz Pająk on Wednesday. So talking about DevOps culture and mindset is actually something really popular recently in our industry. And the order here is not random. The first thing is actually, in my opinion, the easiest one. There are tools that are complex to introduce to your organization to actually start using them. But going down the list, the difficulty increases. And the culture and mindset is something that you cannot read about. Like there is no recipe to actually do it. You need to internally work out some things for your organization. And it's quite a hard thing. So that's why it's the last one. Of course, business folks, depending on the client that you are working with, might struggle with taking your features that you are delivering in a really fast-paced environment because they're not used to working in such a way. And there are layers of management that we need to go through, of course. Okay, so before I going to talk about beyond, let's say some things about the baseline. So how we did continuous delivery with the monolith that we had. So everything here is based on my current project. So these are real life examples that I'm gonna show you. So roughly, this was our architecture. We work with enterprise content management systems. It's AEM, Adobe Experience Manager. And this diagram shows how our project infrastructure looked like. So we had 3 environments that I'm going to talk about later. And it was hosted in AWS. We used Jenkins as our build system. And we utilized Docker for slave management. And we used Selenium for our test infrastructure. Selenium is a great tool presented on SeleniumConf this year in Austin. And it is a wrapper for Selenium Grid, enabling you to actually have really disposable, like truly disposable grid that is easy to set up, easy to manage. And I encourage you to actually check it out because the people from Zalando did a really great job with this one. We used things like Chef, Terraform, Consul for managing and handling our infrastructure, for provisioning things, for configuring things. And of course, we use Vagrant to manage our local repository, local instances. One of the most important things on this diagram is this single guy here. This is our single application repository. Single because this is going to change in a second. And of course, we had a bunch of different Git repositories hosting the infrastructure as code because we manage our infrastructure as code. As well, pipelines, delivery pipelines as well, because with Jenkins, we tried out a new thing that Jenkins provides for about a year, pipeline plugin, which allows you to actually code your delivery pipelines. So we tried that out. It was really interesting journey to actually check how this concept works with Jenkins. And after a year of fixes, it actually works pretty well. All right, for our testing frameworks, we used our open source frameworks that we developed internally at Cognified, so they are available on our GitHub accounts. Actually, AT is something that Radek and Maciej talked about yesterday, so you probably had a chance to see more of it. And Bobcat is our Selenium wrapper. This is our in-house framework that we have created after a couple of years of experimenting with different approaches to test automation. And of course, we use Rest Assured for service layer testing. All right, so when it comes to development process, testing and QA is the most important things for us here at this conference. So we use shift-left approach, risk analysis, and of course, a proper test automation pyramid, where we actually try to implement that one for the first time with a bit of success here and there. But still, this is pretty difficult thing for our organization yet to do. All right, so when it comes to the backlog, so how we define things, we are working, as I mentioned, with CMSs. So we are giving our clients capabilities to build pages internally. So our highest level of abstraction was a page type. Each page type consists of some common features like header, footer, and some page-specific ones like a carousel, for example, or other different components. We used Jira as our issue tracker, and each page type or feature had a corresponding epic in Jira, which we linked with a component. And then under feature epics, we have created technical stories and tasks for the development team to work on. So this was like a tactical level of items that we had in Jira. Okay, so nothing is better than an example. So let's visualize how a single story actually flowed from the very beginning to our end customer. So it all starts in our case with developer grabbing the story, of course. And on the right side, you can see what are the changes in the repository. So we use a simple Git flow, main development branch with feature branches, nothing fancy here. The first thing that developer does is he or she grabs a QA, like not literally, but they sit together in an informal meeting. We call them hugs. There is no hugging though. So they discuss about requirements. If they are clear, if there is anything that needs to be perhaps specified in more detail, they think about different test ideas, like for example, what developer needs to check during the implementation so he can prevent bugs even before they emerge further down the pipeline. And they agree on some responsibilities between them. Developer will test that, QA will test something else. After that, the meeting is concluded. Developer can finally start implementation. So he puts on his headset, thinks about how he's going to implement things, grabs a coffee, and branches out from develop. So he implements things, and at some point of time, when he decides that, in his opinion, he's finished, he tests that feature that he has implemented and decides that, right, I'm done. But since we have different people in the team, there are some features that come in to develop in the meantime. So he cannot be sure that what he actually developed will still work after reintegrating with the main development branch. So he needs to reintegrate with the main branch, grab more coffee, of course, and check if it works. At this point of time, we know that after merging this feature branch to develop, everything will be the same because basically these are the same commits. So the next informal meeting happens, where developer presents the feature that he implemented to the QA, the available one on the space, and they discuss about what has actually happened during implementation, because as we all know, it's hard to predict everything, so there are things that may come up during the development, and they brainstorm about additional things that we need to do afterwards, perhaps some additional non-functional testing somewhere down the line. And it's for QA to decide to actually answer a single question: are all risks defined somewhere during the development, are all risks mitigated or at least addressed somehow, maybe postponed a bit in time? And if not, maybe some additional exploratory test session needs to happen to actually say that QA can accept the story. All right, so the meeting is concluded, and one thing to mention here, everything so far is done locally on our local PCs, thanks to Vagrant. So everyone in the team has local copy of environment, so they can work just as they would, for example, in production. And our QA guy, in our case, it's more often girl, can accept that task story or whatever item we have been working on. And then this feature branch is merged back to develop, and our QA guy can now push the code further by triggering our delivery pipeline build. So now Jenkins comes into play, and we start some automating testing, packaging the application, and releasing it. So this happens on our integration server, so it is like a shared development instance in our case. And if everything is fine, what we end up with is a tagged commit, our release that we have in the code base. Of course, we end up with some artifact. That artifact is kept, in our case, in Nexus. And this is an item that we will be working on further down the delivery pipeline. So what happens with that fellow? We have two servers, additional ones, as you may remember from the diagram, the yellow and the green one. The first one is our staging environment. So this one serves as the target to check if the release is actually deployable. Because it may happen that perhaps the code is stable, but there are some problems with the deployment procedure itself. So what is consistent about these two environments is that on the first one, and on the staging and on production, our King server, we have the same deployment procedure. So whatever happens here on the first one will happen on production. So we can say for sure that if everything succeeds over here, we are safe to deploy to production without any surprises. So we trigger additional pipeline in our Jenkins. Actually, it's triggered automatically after the release. We grab that artifact and we deploy it on staging and run some automated checks. And then we know that our release has been successfully deployed. Now, the business folks come into play. This is also a target environment for them to run some acceptance tests. So they check if everything is working as they requested. Of course, that always happens, right? So they say that, okay, this is what we wanted. We can push that to production. And again, we trigger the same pipeline on production. Everything should be fine, and usually is, unless there are some really specific circumstances around that. And our users receive that features that we have implemented, for example, that additional button that urges them to purchase more stuff from our client. So our clients are happy. Jenkins gets a medal for all the hard work. Okay, so what about the beyond, right? What is the beyond in our case? In our case, to give you some more context, it was the next phase of the project where we had to develop some additional web applications. They were using some dynamic data, a lot of assets. They had some search capabilities. That's why we decided to go with microservices approach. And for our system, how it was structured, before we had only the same platform, but now we named it core to actually distinguish the two pieces. And we added additional applications to it. So a bit complication here. Each application was pretty much similar. It had different modules. It had Solr module, like configuration, Notex. Notex is our, again, internal, also open source tool for an integration tool that actually holds all the microservices in our case. It is wrapper for Vertex and framework for developing reactive applications in Java. And we have some additional AEM pieces that were also part of this application. So pretty much all these were the same. And what we had was a bit of a more complicated system. So what changed in our system? Actually, a lot of things, but I want to talk about 6 of them. So it was infrastructure, code base, how we handled code, Jira and task breakdown, and our CI/CD build. What also changed was the test automation, how we actually handled different suits, and of course, development and QA, because everyone was affected by this change. These 3 elements were complicated even further due to some things that I'm going to talk about in a second. So there were some layers of complications down the road. So now the easy part. Let's start with infrastructure. Infrastructure was a challenging thing because we had only one system engineer that had to work with it. So each of the environment that I talked about now required additional pieces inside. It required Solr master, Solr slave. It required the whole Notex to be set up. It also required some additional configurations in routing between those systems. So it wasn't no effort task for sure, but thanks to the way that we have defined the infrastructure at the beginning, so as code, it was pretty much done almost automatically afterwards, because once we have written the recipes and cookbooks for chef that weren't there, it was like a breeze, because once defined, we could basically provision all these missing pieces to our staging, to our integration, to our production, and of course the local instance. So the team actually didn't notice it. They weren't affected that heavily. So Jira and tasks handling. Since we changed only so much stuff, we decided to go with an experiment, because why not? Why not change even more? And we decided to change the way we defined requirements. We weren't happy with how things worked out before, since each epic that I was talking about contained stories or tasks for developing the backend, for developing the front end, pieces of infrastructure. And at some point of time, it was hard to say that to the client, so is my feature ready or not? We said that, you have like 4 or 5 stories defined, so it's like 90% done, and such state consisted through the whole development. So we weren't happy with that. Client wasn't happy, and decided to do something about it. And we also changed the way we actually define the requirements. So we described them in Gherkin. So no, we did not do BDD. We only used Gherkin as our way of describing features. And we have decided to actually create more business-oriented tasks, like business user stories, which describe a whole scenario or a group of scenarios that actually delivered some value. And it included back-end, front-end, the necessary pieces in infrastructure, the integration part. Everything was done in the single story. And due to the reasons that I'm going to talk about in a second, Jira and Bitbucket integration, a small thing, actually helped a lot to our development team, because we had more repositories. Now, test automation. Now we did not have only a single system. We had a couple of them, and we needed to test them in separation, because I didn't want to run a test suite for application 2 when I was testing application 1. So we needed to define a suite per app, and we needed them to be run based on context. So again, I'm testing application 1, I don't care about the rest. Defining the suites was actually pretty easy, because the tools that we have used was a matter of adding some additional categories or adding some labels here and there. But now if you imagine the tasks, all right, we have a single run, and now we have different suites. We ended up with like 15 or 17 of them for each environment. Creating these jobs by hand would be a pretty mundane task. So thanks to the way we have defined our pipelines as code, was only a matter of specifying some small configurations, and they were almost automatically generated. I'm going to show you in further slides how we actually achieved that. And of course, with running so many tests, the most important thing was the execution time. You don't want to wait like half an hour for everything to be done, or even more, because after, like, my sweet spot is like 5 minutes, like maximum time of execution for a single job. And 15 minutes is something that I can work with. This is the time where your developer will not switch context or grab a coffee or start working on something else. But this also requires an infrastructure that will actually handle parallel runs. So Selenium helped a lot over here, because we didn't have to suddenly spin up multiple containers. We actually had that handled by the tool itself. So whenever we hit with more test suites, it actually spawned more containers underneath, and it was all seamless for us. So now, the true complexity, everything else. It was first it was about the code base, because as you remember from the first diagram, we had only a single repository. But after these new applications started coming into our system, we had a repository per application. So we did not decide to go with a single mono repository. We actually decided to split them based on their business domain. So we ended up with almost 10 repositories. There were some additional repositories for some common functionalities that, for example, application 1, 2 were also using. And defining infrastructure as code, defining pipelines as code also requires a repository to have. So we ended up with almost 30 repositories containing everything. So it wasn't about only checking out and branching in a single repository. It was about branching across 30 of them. System engineer that had to do the most of the work over there. So as I mentioned, each repository had, each application had its own repository, but there was one small issue that we have run into with such breakdown. Since our backend was broken down into microservices perfectly, the front end was not. So application 1, 2, 3, there were 4 or 5 later, had their front end kept in the core repository. So whenever we were working application 1, we had to pull application 1 repository and pull the core one and build these two. If you wanted to work with application 2 that used, for example, service A, you had to pull 3 repositories. This was pretty painful for our QA engineers that had to juggle between them. And of course, why care about consistency? So one branch could be named differently across all of them. And it was fun, right, Patricia? So this also brought a challenge to actually releasing and deploying things, because you had to somehow define the relationships between these, because Jenkins had to know that, okay, I want to build application 1, so I need to check out and manage the first repository, the core repository, perhaps one of the services. And this was a pretty complex problem to solve, but we found a pretty nice solution to that. And again, you remember the process that I showed you, so now it wasn't about a single repository. Everything that has been done previously with that one code base now had to be done across multiple ones. So again, the developers were not so affected because backend guys worked mostly on single repository containing microservices. When they had to integrate, that was a pain for sure, but the QA folks were the ones having to struggle with it continuously across the process. So other things is more technical testing was required. We had a backend, really complicated backend. So you had to check all these integrations. You had to check some HTTP requests that were flying around. You had to monitor and grab logs, not from a single system, but from multiple ones. So it was really, really complex thing to first introduce to our team. But I think we ended with a nice situation. Since there were lots of backend and front-end integration, as a way to also somehow define and communicate some requirements, we had to introduce contract tests. So for backend and front-end developers to have something in common that they could work on, we introduced those tests. And of course, maintenance problem came up because not always these tests have been updated, and that was actually related not to the technology, but to communication. One thing also that was pretty painful, since these applications were working with a lot of assets, it was like gigabytes of images, like poster images. Now we had a challenge to generate the smallest test package containing all the necessary elements. So front-end guys were satisfied, QA guys were satisfied with having a set of data that covered most of our test cases. And since we had like 3 or 4 applications, you had to manage now gigabytes of data, so naturally it took some time to download. Hopefully if you were in the office, that wasn't the case, but working remotely was painful. And what is most interesting, since our system scaled, so did our communication needs, because now it wasn't only about a single thing, it was about multiple ones talking with each other. So that also was reflected on the way we had to talk in the team inside our development folks, because backend guys with frontend guys had some issues that they needed to discuss. QA had to actually talk with all these people to get the whole picture of a system. And this is something that we maybe weren't prepared to handle, but it came up during the projects, and most of our problems were related to that element. So unfortunately, we are still struggling with that due to various reasons, but we had the toolset sorted out, but the communication culture, not so much. And work in local environments. Now you had a system that you had to build, like multiple pieces. So our integration, staging, and production had Jenkins to handle that. Locally, not so much. So QA had to build single repository this way, that way, that way, and then deploy all these artifacts on Vagrant. And this is still a thing that we need to sort out, so hopefully we'll find a solution soon. When it comes to our CI/CD build, now Jenkins had to work on multiple repositories. Again, we had to know which repository to check out, what branches actually needed to be checked out from these repositories. And since all these applications contain different modules, these modules were deployed and released and in generally managed in a different way. And of course, none of them were consistent, so we had to somehow define what is actually happening with each of them. And again, execution time. Now, it wasn't about a single system, but it was about a system of systems. So we didn't want to wait hours for rebuilding things, especially that we wanted to do them still continuously. So we had to introduce something that handled that for us. And it is the best shown over here on these visualizations from Blue Ocean. This is a plugin that will perfectly show you Jenkins pipelines. So if you're working with them, this will help a lot. And all this here was hard-coded. So we defined its stage in the code. So each of them was actually specified straight away. And this was what we ended up with after switching to microservices. What is really interesting about here is all these parallel stages were not defined like straightforward in the code. They were generated dynamically based on the choices that person triggering made. And this is only until the build phase, the test phase. This is the remaining release phase. A separate pipeline introduced for the way we worked. We managed to make it so people triggering the build only had to specify which repository they want to build, provide the name of the branch that they wanted to build, and everything else was done automatically by Jenkins. So it was only about the knowledge which repositories you need to build and what revision you want to work with. So we hidden all these complexities around building, releasing, and deploying things underneath. How we did it was by introducing some configuration management to our pipelines. You can see it on the right. It's each repository it's a YML file with some properties of each of the applications that we had, each repository that we had. it contains some details about how to, what credentials you use, what are the contents of repository, so what modules were included inside, and what tests we need to trigger after running each of the repositories. And this is like a rough, like part of the pipeline. It was like a couple hundreds of lines in our script. And in general, it pulled that configuration and based on that, generated all the steps on the fly. So this is something that you can do with pipelines. So adding new repository was only a matter of providing that configuration. So we didn't have to code anything else afterwards. And other neat things that helped us was Docker, that actually made the slave management seamless, because if something broken down, we simply killed the container and raised a new one, and we didn't care about why it happened. And maintaining all these hard-coded machines wasn't an option. And part of the pipelines, so Jenkins pipelines are defined in Groovy, but we didn't want to code everything there because we had some build scripts already written in projects. Especially part of the deployments procedures were handled by Chef, so we utilized some of that, and parts of the pipeline are underneath triggering Chef scripts. With pipelines, you can also have a library, so you can extract all the common parts and share across different teams. So, for example, if you are working in your organization with the same technology stack, you can pull all that into a single shared library and share across teams. So you can, recently I started to write a lot of posts, and I will write a lot of posts about Jenkins pipelines, so you can check it out how to actually do it. And lessons learned. So microservices are hard. Everyone knows that. But what we realized, they are harder than you actually think at the beginning, because you don't think about how it's going to affect your communication requirements, how it's going to affect your organization. And sometimes people do not realize that there are some other challenges related to that. Multiple repositories are a pain. So you have to ask the question, do you want to actually handle all these separate ones, or should you go with mono repository? There are projects doing that perfectly. Selenium is, for example, an example of that. All bindings are kept in a single repository. This, of course, introduces other challenges, but it's up to you to decide which way you want to go. And it will have an enormous impact, not only on the way you work with code, but also how you're going to build, test, deploy things. And your continuous delivery process needs to be scalable. It's not only about the tools, only about infrastructure, but all about the very process itself, like all these communication needs, all these elements related to working with requirements, with how you define things, how you deliver things. And they need to be flexible and scalable. So your process needs to scale as well. And infrastructure as code and pipelines as code is something that you will want to introduce at some point of time, because our systems are getting more and more complex. So if you are not doing it in your organization, you probably should, because it will save your day, month, year, and maybe even the project itself. But what people not see or think about first is that we have application repository, we have pipelines repository, and we have infrastructure repository. This is the code, this is the code, and this is the code. We need to test that, this, and that. So you also need to test these repositories. Actually, at some point of time, our infrastructure had more automated tests than the application itself, because guys took care of that really great. They did a really great job. So we had automation checking our infrastructure. Pipelines are still a fresh concept, so there are test frameworks to do that. But we haven't implemented that yet, and it is a pain because now we have a lot of logic in our pipelines, and in general, changing anything is a bit scary because, well, you may break, for example, the production deployment. And technology will not save and solve all your problems because, as I already mentioned, communication and culture issues were actually the things that introduced a lot of problems in our project. We had the tool set sorted out. It wasn't an easy journey for us. It was a couple years to reach that point. But what we now struggle with is basically speaking with people inside the team because they weren't prepared for so many discussions to happen. They wanted to simply code. They weren't used to, in some cases, to actually had so many discussions about how we develop things. And you need to communicate all of that. You need to talk about how you build your system, how you deploy the system, how you release the system. And this is a knowledge that needs to be shared across all team members. Otherwise, you end up with single point of failures in your team. So, yeah, unfortunately, technology is not a silver bullet for everything. And a quote perhaps for the future is that test, DevOps, or whatever ops you put there, people are adding all different words before ops, is an important piece of designing really quality, focused delivery pipelines. Because there was a great workshop, there were great, on Wednesday, there were a couple great talks about that. It's about having that mindset and actually building that culture in your organization to actually have these processes in place. Otherwise, you end up with some perfect tools that do not work together because you don't have anything that keeps them together and making them work. If you want to check out more technical things that I was talking about, you can visit Kuba Wondolowski's presentations. He is the system engineer that actually did most or a lot of that infrastructure piece. And I already mentioned that I'm writing about pipelines, so he was the one defining infrastructure, I was the one defining the pipeline, so feel free to check it out. And thank you. That was everything that I had to say. If there are any questions.